Sir, sir, കേൾക്കാൻ പറ്റുന്നുണ്ടോ sir? Sir, കേൾക്കാൻ പറ്റുന്നുണ്ടോ?
Audible ആണ്.
സർ 2 മണി വരെ ലഞ്ച് ബ്രേക്ക് ആയതുകൊണ്ടാണ് സർ നമുക്കൊരു 2 മിനിറ്റ് കൂടെ വെയിറ്റ് ചെയ്യാം സർ. സർ ഓഡിബിൾ അല്ല സർ. സർ ഓഡിബിൾ അല്ല. ഐ.ടി. മിഷനിൽ ആരെങ്കിലും ഒന്ന് സാറിന്റെ ഓഡിബിൾ അല്ല.
ഓഡിബിൾ ആണോ?
ഇപ്പൊ ഓഡിബിൾ ആണ് സർ.
Okay, thanks. And just check whether my presentation is also visible in the presentation mode.
വിസിബിൾ ആണ് സർ.
Okay, right, thanks. No issue.
നമസ്കാരം. നമ്മൾ വെബിനാറിന്റെ സെക്കൻഡ് സെഷൻ ആരംഭിക്കുകയാണ്. ഗ്രീൻ ഹൗസ് ഗ്യാസ് എമിഷൻസ് ഇൻവെന്ററൈസേഷൻ ആൻഡ് മിറ്റിഗേഷൻ എന്ന വിഷയത്തിൽ നമ്മളോട് സംസാരിക്കുന്നത് ശ്രീ നായർ നന്ദകുമാർ സാറാണ്. അദ്ദേഹം കാർബോറണ്ടം യൂണിവേഴ്സൽ ലിമിറ്റഡ് കമ്പനിയുടെ മാനുഫാക്ചറിംഗ് ഓപ്പറേഷൻസ് പ്രോജക്ട്സ് ഓഫ് ഇലക്ട്രോ മിനറൽ ഡിവിഷൻ തലവനാണ്. അദ്ദേഹം ഇലക്ട്രിക്കൽ ഇലക്ട്രോണിക്സിൽ ഗ്രാജുവേറ്റും ബിറ്റ്സ് പിലാനിയിൽ നിന്ന് MS കരസ്ഥമാക്കിയിട്ടുള്ള ആളാണ്. സ്മോൾ ഹൈഡ്രോ പവർ ജനറേഷൻ, ഗ്യാസ് ആൻഡ് സോളാർ പവർ ജനറേഷൻ ഫീൽഡിൽ 3 പതിറ്റാണ്ട് പ്രവർത്തന പരിചയമുള്ള അദ്ദേഹം സദേൺ എനർജി ഡെവലപ്മെന്റ് കോർപ്പറേഷന്റെ ബോർഡ് ഓഫ് ഡയറക്ടേഴ്സിൽ ഇൻഡിപെൻഡന്റ് ഡയറക്ടറും കേരള ഹൈ ടെൻഷൻ എക്സ്ട്രാ ഹൈ ടെൻഷൻ ഇലക്ട്രിസിറ്റി കൺസ്യൂമേഴ്സ് അസോസിയേഷന്റെ പ്രസിഡന്റും KERCയുടെ അഡ്വൈസറി കമ്മിറ്റി മെമ്പറുമാണ്. കൂടാതെ നാഷണൽ സേഫ്റ്റി കൗൺസിലിന്റെ എക്സിക്യൂട്ടീവ് കമ്മിറ്റി മെമ്പർ കൂടിയാണ് അദ്ദേഹം. നാഷണൽ സേഫ്റ്റി കൗൺസിൽ കേരള ചാപ്റ്ററിന്റെ ഹെൽത്ത് സേഫ്റ്റി എൻവയറൺമെന്റ് ഫോറമിന്റെ കൺവീനറുമാണ്. അദ്ദേഹം ഇന്ന് നമ്മളോട് ഗ്രീൻ ഹൗസ് ഗ്യാസ് എമിഷൻസ് ഇൻവെന്ററൈസേഷൻ ആൻഡ് മിറ്റിഗേഷൻ എന്ന വിഷയത്തിൽ സംസാരിക്കുന്നതിനാണ് ഇതിനായി അദ്ദേഹത്തിനെ ക്ഷണിക്കുന്നു.
Thank you, Reshma ma'am. Good afternoon to all of you. I hope my voice is audible.
Audible answer. Audible answer.
Thank you. So at the outset, let me congratulate the officers of the Kerala State Pollution Control Board and the people who worked behind hosting this webinar. The day, a very important day as a Ozone Day for a very relevant and contemporary topic. So congratulations to all of you, and also for the opportunity that has been given to me. In specifically, I would like to thank Nobisa, Sri Lakshmi Madam, and of course Reshma Ma'am, who has been coordinating for the kind courtesy and also coordinating with this whole process. Thank you very much. Also thank all the participants for setting aside their valuable weekend time to be present here. My talk in this afternoon session after lunch is no doubt a little difficult to digress, but I will try to be as simple and lucid as to the extent possible. The topic is not so simple, but I have a little simplified it for the people who are new to this. I'm sure the audience comprised of people who have done far more work than what we have done, and also knowledgeable about the topic that I am talking about. But this is more for the people who are new going to get initiated into this important aspect of greenhouse gas emissions and how do we quantify it and how do we mitigate it. So I will try to also close my talk within an hour. So over to the next slide. In the morning session, we heard two speakers, Sumi Madam and Premalata Madam, speak exhaustively on the important role of ozone layer above us and the ill effect of the ozone depleting substances, and also the regulations of the land that has put in place to ensure that we reduce the ill effects of this ozone damage. In continuation of what we have spoken in the morning session, I'm going to speak about greenhouse gas emissions, its inventorization, and the projects that can be taken up to mitigate the greenhouse gas emission impact. Before I start talking about greenhouse emissions, maybe to bring a synergy between what I talk and what you comprehend, I'll quickly touch upon the ozone depletion issue as well, and also try to explain the linkages and differences between the actions of what the ozone hole impact versus the GHG gas emission. Morning, the first speaker, Dr. Sumi, of course, touched upon how the ozone cannot be looked at isolation, how the climate change also has an impact. But a little getting into my topic, I try to link. The 16th September is commemorated as Ozone Day to bring awareness on the ill effect of certain chemicals and substances that harm the ozone layer that is above us, above our atmosphere. But is it enough with the remedial actions that we have taken to mitigate this? Of course, actions to reduce the damaging impact on ozone is very much required, but in reality, it is not sufficient and not enough. In the morning, Dr. Sumi talked about the leakages of ozone depleting substances and also how it impacts the climate change. So we cannot talk the issue of ozone issue in isolation. While we agree that remedial action is indeed required to protect the ozone layer, we should also be aware that many more emissions by mankind are released into the atmosphere and causes damage to Mother Earth and can cause damage to our planet. And these substances include the greenhouse gas emission, not the greenhouse, it also includes the greenhouse gas emissions, which we call as GNG in short. So we need to address holistically this issue of GHG emissions along with the ozone depleting substances. And that's why there are so many issues that affect the sustainability of the planet, and we need to look at holistically. And that's why the United Nations has brought out 17 sustainability development goals, in which the climate control has got a very important role to play. Man's activities are always destructive. I would always say that it upsets the equilibrium of our life cycle of the planet. You take any activity that we do, for example, God created man, or whoever is our creator. when he created us, he made us very simple, and his expectation would be as simple as any other animal. So we were also in the initial stages tuned to eat raw food just like any other animals. But the discovery of fire, with the discovery of fire, man started changing his lifestyle and started to eat cooked food. And in the process, started an additional pollution through the release of carbon dioxide into the earth. And not only carbon dioxide, depending upon what source of fuel that you use for cooking, again, you are polluting the earth. So in a sense, if we look back at our own activities that we do every day and everything that we do, it damages the earth and its existence in one way or the other, whether you are cooking, whether you are driving, whether you are using electricity, or whether the factories that we work, or even the launch of missiles and space rockets, which was mentioned in the morning, cause immense damage to the earth. But when knowing all these things, should we denounce all these luxuries and lifestyle and forego this to save this Mother Earth? That's a question that you and me need to answer. But to me, the answer is quite simple. We don't have to. But rather, our behavior has to be modified, and we have to work a little more responsibly. And that is why the UN's 17 Sustainability Development Goals are established, in which this climate control is given an important role. And in continuation of that, a recap of what we learned in the morning is what I have shown on the slide. I'm not going through each of the words that are shown there, but the redeeming part of the whole process is that the ozone hole that has been formed is slowly healing and is showing signs of recovery. But as I said, we cannot talk about ozone protection in isolation when we talk about climate control. And so the role of greenhouse gas emissions, which are far more destructive, are indeed an issue to be addressed. And we need to look at how do we address that in near future. Again, in the morning, the madam talked about the substitution fuels for ozone depleting substances, which are hydrofluorocarbons. But these replacement substances like hydrofluorocarbons are also powerful greenhouse gases. So what happens is, when you substitute for the benefit of ozone protection, it also results in creating 1,000 times more potent damaging gas release into the atmosphere, which causes greenhouse gas effect. So a successful HFC phase down is now started to reduce our global temperature. And that is why, as I said, the purpose of today's talk should not be merely about the actions taken in the ozone layer protection, which is actually seeing results. And if we continue without fail, whatever measures we initiated and whatever measures we have planned, we would be definitely achieving a revert back to 1985 status of the ozone layer. But we also have to urgently and proactively work towards reducing the greenhouse gases. Now, what is this greenhouse gases? Greenhouse gases are some of the gases that are released into the atmosphere because of our own actions. As I said, our actions create damage to environment. So when we breathe out carbon dioxide, which is how the God has created to us. But beyond that, when we discovered the fossil fuel, we started burning them. We started using it for electricity. So burning of that caused carbon dioxide release, which is called a greenhouse gas. Methane, again, used as a natural gas system in agriculture for the manufacturing of fertilizers, again, is a release and is a greenhouse gas. So similarly, HFC, PFC, SFC gas, all nitrous oxide, all these are classified as greenhouse gases, which invariably we use in one form or the other. So coming back to the greenhouse effect, what exactly is a greenhouse effect? In fact, greenhouse effect is not all that bad. The greenhouse effect is the presence of these greenhouse gases actually helps the environment. In what way? If there was no greenhouse gases, our earth would be as cold as minus 18 degrees centigrade. So what do you mean by minus 18 degrees centigrade? It means that life cannot be possible at that kind of temperature. So, in fact, the greenhouse effect or the greenhouse gas creates an effect of a greenhouse, and meaning that it's a glass house. The name is derived from the glass house, where the temperatures get controlled automatically. So basically, it is carbon dioxide in the atmosphere that absorbs the long wavelength of the infrared energy from the Earth and then re-radiate it, some of it backwards, and effectively trap the heat inside the Earth. Now, where does this infrared radiation comes from? This infrared radiation, of course, comes from sun. So in the morning, we talked about ozone depletion, which is also happening because of the ultraviolet rays from sun. So sun's rays contain ultraviolet rays and infrared rays. Now, ozone depletion is caused by ultraviolet rays, whereas the greenhouse effect is created by the infrared rays. Whereas if there was no big greenhouse emission, in the normal circumstances, the whatever greenhouse is created by the life cycle of how the creation was planned, it would have helped us to keep the Earth's temperatures much more at a higher level, thereby allowing the life on Earth to be more livable. And the major gas, as I said, is carbon dioxide, along with the other gases that I mentioned earlier, allow the visible light from the sunlight, especially the high long wavelength infrared energy from the sun, and keep the atmosphere warm. Now, so imagine if there was no greenhouse effect. So basically, is greenhouse effect or in greenhouse gas good or bad? If I ask this question, the answer is quite simple. It is very crucial to keeping this planet livable and inhabitable. Otherwise, it would be a very, very cold planet for us. So in a way, it is a good thing. It keeps the planet warm, keeps the Earth also warm, it keeps us livable. But without it, at the same time, as I said earlier, the man's action is very, very destructive. Everything that we do causes damage to the atmosphere. So when we release additionally over and above how the nature has designed to be released, release of greenhouse, when we additionally create this greenhouse and release into the atmosphere, it causes more harm than good. There's a very pertinent saying in Malayalam, the Adhigamayal Amrudam Avathu. So in the same way, when you let out more greenhouse than what is required for the nature, through the burning of fossil fuels, through our actions releasing certain gases like methane and HFCs, it tremendously increased the greenhouse effect. And the impact is what we call as the global warming. And because of the global warming, we see that the climate change happens, the glaciers are melting. You find the glaciers are melting. You find that melting of the glaciers results in tremendous increase of water level in the sea. And the increasing water levels, the more the temperature, it will start more and more, causing submergence of our many of the land spaces. Land is very little in this Earth, and if it starts submerging, it's going to cause a great damage. And if you also look at it, it's also causing a damage by climatic change to biodiversity. So fresh water is getting reduced. So it is a question of survival time. Now, the ozone impact, we talked about remedial and results being seen, a concerted action that has been put in place. And the impact, if you see, is on the personal level, where it can cause a skin cancer, it can cause damage to biodiversity, or it could be more personal level. But if you look at this GHG, it can damage the entire planet in one go, and hence it has to be reverted back at least to a lower level, if not. So we are trying to limit this global temperatures by 1.5 degrees Celsius. So what are these greenhouse gases we mentioned is happening? On the right side, if you really look at, can you see my pointer? Hello.
Yes, sir. Sir. Yeah. Sir.
Yeah. Okay. Just a minute. I just wanted to take the pointer. It's not coming. Okay. Right. So if you look at this right side of the presentation chart, you'll find that the impact of GHG emission is highest from the energy sector. Of course, industrial processes, agriculture, waste, land use by due to forestry change and other fuels are all there. But the biggest impact, if you look at a Pareto, the area to be addressed would come as energy, which is 72% by sector. And where is this energy used? Energy is used for generation of electricity and heat. On the right side, you see the split of 72%, and you can see that 31% of the energy is utilized for power generation and heating purposes, especially in cold countries. And then in the manufacturing sector, we are using close to 12.4%. And transportation sector, where we are using the vehicles and other things, we are using 15%, and other fuel consumption 8.4%. So this is a major area where if you look at intensely, I'm sure that we should be able to bring about a phenomenal reduction in our GHG gas emissions. And since, as I said, that all the nations have now taken very seriously, India too has committed itself towards reduction of its emissions. And what is India government's target? India government is aiming to be net zero by 2070. And this comes, as I said, because the fuel is a major portion, power generation is a major portion. The government is looking very actively in generation of renewable energy from solar and wind and other renewable source of energy, and trying to cut down on thermal and other fossil fuel based power generation, which would bring a significant impact on our greenhouse gas reduction. Having said this, what is when the government takes such an action of 2017 net zero, it also means that at the lower level, when the government cannot do anything, it can only bring rules and regulations in place. But it also means that we at our individual level, the companies and industries at their level, the corporates, and also the power generators, everybody would have to take very, very concerted action to reduce their emissions level, which would be later on, I'm sure it would be mandated by law, but as of now, it is voluntarily required. And this would bring about a target, achieving the target that government has set aside. And what is it, the role that industry can play in reduction of GHG? So as I said, the energy sector, industries and companies are a major guzzler of energy. They need, every industry would require power to run its plant. And so in terms of reducing the GHG emission, there are two ways. One is reduction of energy, resource reduction or resource optimization. So if you do energy conservation, if you reduce a specific energy consumption, if you produce more with less energy, definitely you are reducing your greenhouse gas emissions. Second, also the impact of the climate change environment, if you know, then you can also start looking at substitution of the more intense GHG emitting sources with less emitting or with neutral grade. So this is where the industry's role comes in. So when industry looks at GHG gas emission, it has to look at it very different manner. And so the requirement is broadly is classified into three ways. Industries create greenhouse gases in three sectors. One is the direct emissions that the industries let out, and it comes under scope 1. Second is the indirect emissions that the industries let out. I'll come to it in more detail. But the indirect emissions that industries let out into the atmosphere are classified as scope 2 and scope 3. So unless the scope 1 is the direct emission is reduced, unless the scope 2 emission is indirect is reduced, a significant reduction cannot happen. And once that significant reduction comes in, I think industries would have to start looking at their boundary conditions into the another boundary conditions, which they would be required to look at slowly to help India to attain its committed goal of net zero carbon by 2070. Now, what I will let us understand what exactly is scope 1 emission. So if you understand what is a factory is all about, a factory is a place where you use a raw material, and this raw material undergoes conversion through power, use of power, and from this use of power, it is converted into finished goods. Now, whatever operations that is done inside the factory after the receipt of raw material, after the receipt of raw material, and whatever you do to have your product packed up, what is done inside the factory, inside your boundary, and in the process, whatever greenhouse gases that you emit would all come under the scope 1 emission. So the first step for industry is to look at its own operational practices and processes and look at how do we reduce the scope 1 emission. Now, what is scope 2 emission? Scope 2 emission is to run this factory, you need power. Now, where does this power contribute to the scope 3 emission? And similarly, you have employees working inside your factory, you have vendors, you have suppliers, you have people coming inside to the factories, commuting to the places. So how do they emit the greenhouse gases when they commute to work to your factory is also under the scope 3 emission. So your employees, though they are using the vehicle, they are coming by bus, they are coming by bike, they are coming by car, and then they are absolutely, as I said, mankind releases pollution. They are also releasing pollution. That is also a greenhouse gas. So that is also to be controlled, which comes under scope 3 emission of the factory. Now, scope 3 is also about the finished goods. When you transport it back from your factory to maybe intermediate warehouse, from there it can go by sea, it can go by road, flight, whichever way you transport it, causes greenhouse gas emissions, and they are classified under the scope 3. So these are the 3 ways in which emissions are first categorized in the factory, and the quantification has to be done under each scope, and then only the reduction targets can be thought about. Now, the process step, having understood what is scope 1, scope 2, and scope 3 for an industry in terms of GHG emission, let's look at how you go about with the process of first inventorization, nothing but taking stock here, and then planning to reduce the steps. So on the left side of the vertical dotted line, you see the blue boxes, which is all about my status scope. That is, where am I standing today without even taking any mitigation action, is to identify what are the sources of emissions that I do. And second, I'll be using maybe gas or maybe coke. So I'll be using different sources of materials that would be releasing GHG. So it has to be commonly converted into an understandable unit rate, which is in terms of the kilograms of carbon dioxide emission. So carbon dioxide emission is taken as unit 1, and every other source of emission is converted into a common scale of equivalent kilogram done in terms of identifying where do I stand today. And once you know how much you are emitting, from there comes the reduction action, as you see the green side. Now you decide how much is I should plan, and then start a mitigation project. You can target 25% reduction, you can target 10% reduction, you can target 100% reduction, but it should be a realistic target. And when you take a target and you need to take mitigation projects, you have to implement certain projects which would offset this kind of emissions, and that calls for a significant investments. And those investments, once is in place and implemented, would lead to a reduction. And again, you go back to the left side to calculate how much is the new emission, how much is my per ton of emission, like energy is in specific energy, carbon or GHG emissions is in terms of kg per carbon dioxide per ton of the production. So this has again go back and again work back forward towards further reduction. So it goes on. It's a PDCA cycle kind of a thing as you target more and more reduction over a longer period of duration. Now, how is this calculation done? Let's typically look at it's in a very simplistic term. I would define it in which you can do the GHG calculation. The first step towards quantifying your GHG emissions is to identify what are your emissions, what do you release, or what do you use in your inside your factory for scope 1 would be maybe diesel, maybe graphite, maybe acetylene gas you may be using, fire extinguisher you may be, so CO2 you may be using kerosene, you may be using air conditioners, R22 refrigerants you may be using, of course, electricity you are using. So you have to first of all calculate the equivalent emissions that you release into the factory. And second is to convert that GHG of tons into the equivalent tons of carbon dioxide, equivalent tons or equivalent kg of carbon dioxide. And how do you do this is to multiply the GHG tonnage by an emission factor. For each of the emissions, there is a emission factor which we will have to identify, and you multiply that, you will get a common unit of equivalent tons of carbon dioxide, which can then be added up to form your net emissions in terms of equivalent tons of carbon dioxide. So this is how you quantify your overall GHG emissions in a year or in a month, in whichever period you want to estimate. So if you look at my emissions, or I'm just looking at, I'm giving you a list of items that we use inside the factory. So we have inventorized the emissions that we use in scope 1 and scope 3, except for the last one, which is grid electricity. The rest of the things are inside the scope 1. You find the diesel, graphite, petcoke, acetylene, SF6. All these are all used inside the factory in one way or other, in big quantity or small quantity. Some in a larger quantity, some in smaller quantity. Some SF6, for example, is not a raw material, but we have a substation where an SF6 circuit breaker is used. So if you look at electricity board, they may be having huge SF6 circuit breaker, where I would have only one. Maybe some other industries, smaller HT industries, smaller LT industries may not have it all. So you inventorize what are the kind of materials that can cause GHG emissions. And those emissions, if I have used it for that year, you will have to calculate it. Now, this multi-emission factor is the factor by which you quantify the quantity of diesel to get the equivalent of kg. So you see a sample calculation. For example, if I have used 175 kiloliters, it means 175,000 liters of diesel in a year, my multiplying factor would be 2.64, equivalent of diesel. If you look at emission factor, I would get 462 tons of carbon dioxide equivalent is the energy emission that I let out in a year. So similarly, if I look at carbon, if I use the same unit, it's not the same unit, I'm using different quantities, but I'm just giving you for the sake of understanding. If you're using graphite 175 tons, you have to multiply by 0.0. If you use SF6, you multiply 175 with its multiplying factor of 23,900. It's a very huge quantity of carbon dioxide. So in relation to carbon, you now know that how much of more impact each of these gases have. So SF6 is 23,900 times more dangerous than carbon dioxide in terms of greenhouse emission, whereas kerosene is only 0.439 times of damaging as compared to carbon dioxide. And scope 3 is electricity, which is 0.79 times if you take from grid. Now, where do I get this multiplying factor? So you normally there are different ways you get it, but the most realistic and optimal is to take from the what you call as Intergovernmental Panel on Climate Change (IPCC) data book. You can refer for each of these multiplying factor, emission factor, and once you quantify how much tonnage of your GHG taken from your IPCC, and if it is not available in IPCC. Maybe some of the data like grid electricity may not be available in your IPCC. So you would have to base data specific to the Indian power sector data. So if the international data is not available, you can refer the Indian data. And if still there are certain data not available, you can also internally calculate it also. Sorry. So if you look at this, the quantification of our basic GHG emissions. Now, if you look at our CO2 emissions becomes the largest, and rest of the portions that we contribute in terms of GHG emissions are far more less as compared to carbon dioxide. Excuse me. So I come to the result of what now based on this. Once we have quantified this, as I said, you put in place the mitigation projects. I'll come to the mitigation projects, but before I get to the mitigation projects, we started this project in 2018-19, and the study is by an independent third-party agency, which is the Confederation of Indian Industry Green Business House, Godrej Green Business House, Hyderabad, who are the pioneers or leaders in this field. In fact, CII, Godrej Green Business House, is also the agency doing under the aegis of Bureau of Energy Efficiency. They have conducted a study for the Kerala state also. Incidentally, unlike India, Kerala state is targeting to be net zero carbon by 2050, not 2070. And to reach that net zero carbon by 2050, CII Green Business House has done the study for the Kerala government through EMC support, and they have submitted the draft report. And they have also done for us, and we started a little earlier in 2018-19, and the base year on which we have calculated this emission. And from there, each year we have put in place various mitigation measures. And just for your information, I am just, we have done the scope 1 emission and scope 2 emission study, quantification and the mitigation. And you can look at a scope 1 emission in 2018-19, the first graph, was 0.229 kg or ton carbon dioxide per ton of our production, which has been progressively reduced in 2022-23 to 0.176, which is a 23% reduction. Now, if you look at scope 2, which is primarily the electricity that we consume from the grid for the operation of the factories in Kerala, this study is exclusively, what I am presenting the data is exclusively for the factories of Kerala. We have done similar studies in all the factories in India, whether it is in Tamil Nadu, whether it is in other locations of India, and each is an independent study. This is purely related to Kerala. And in scope 2, where the electricity reduction of GHG emission, 2.446 was the emission per ton of production, has been significantly brought down to 1.835 in 2022-23, that's the last year. And in current year, we see a further reduction happening in both scope 1 and scope 2. And the combined, of course, it is scope 1 is one area, scope 2 is second area, and it is a combination of scope 1 and scope 2, which is the carbon emission or the carbon footprint created by the company. And so if you look at the overall scenario in terms of total emission for scope 1 and scope 2, you find that from 2.674, which was the GHG emission in 2018-19, has been progressively dropped down to 2022-23, where it was 2.011 per ton of production, which is 25% reduction has been achieved over last base year. And further reduction is still to 2.011 that we achieved last year. So how do we make this happen? As I said, this reduction cannot happen automatically by inventorization. Inventorization is to know where am I standing as of now. And from there, after a mitigation measure is taken out, you again calculate and look at have I achieved the reduction or not, and then look at next set of mitigation projects. So I'm sharing with you a couple of mitigation projects, but what are generally the mitigation projects that are done for reduction of GHGs for scope 1 and scope 2 is I'm sharing today in a broad fishbone diagram. One, you can do operational improvement. And what are those operational improvements? You can look at optimizing your production processes. You can bring more concentrated, focused monitoring of your processes to avoid idle running or idle wastage of fuel or idle conditions. And also improve your systems. How do I improve my energy efficiency? How do I conserve energy and reduce my energy consumption per ton of production? How do I reduce my material consumption? How do I reduce my material consumption by this, adopting circular economy? Recycling is an important step towards GHG mitigation. Again, clean fuel adoption. As I said, if I'm using an LDO or SKO as a fuel, I can look at LNG as a fuel substitution, which is a cleaner fuel, or electricity, or whichever biomass or alternate technologies to substitute from a higher GHG emitting fuel to a lower fuel which is much more lower in terms of GHG emissions is one way to look at GHG mitigation. And in terms of the scope 2, which is energy, look at renewable energy inside. If I put solar, I can reduce my power consumption taking my grid energy. So if you put a solar in your rooftop, you are contributing significantly, not only to save your electricity bill, but also helping this planet by reducing your GHG emission, because you are reducing electricity from the grid, which is primarily from the thermal sources. Now, also waste to energy. If I were to get heat from my waste and recycle it or reuse that heat, again, that is also a way to reduce my GHG emission because it reduces the use of electrical energy. There is also a new scheme that is coming up where you can put up renewable energy power plants outside your factory. So it will not be located inside your factory. It could be an off-site energy projects. And those energy projects can be two ways. One, it can be my own projects, or I can purchase from the grid itself. From the grid, I need not buy from the electricity board. I can buy green power. So it's called a green energy. If I buy green energy, I am again substituting my GHG. So when I say if you want to put your own project, it calls for investment. And when you are buying, again, it means that you are buying a costly power based on how it is available in the grid. And of course, everybody knows that tree plantation, a tree in this world that gives you free oxygen to breathe in whatever we let out into the atmosphere in terms of carbon dioxide. But trees have limitation that it cannot fully mitigate the GHG emissions that we let out into the atmosphere. But to the extent of carbon dioxide mitigation to a very reasonable level, tree plantations, of course, have to be encouraged and supported. So tree plantations, of course, is one of the mitigation methods. And in terms of transportation, again, embracing renewable energy sources and electric vehicles in terms of fossil fuel. As I said, substitution to cleaner fuel. Electric vehicles are far more cleaner than fossil fuel. But still, the electric vehicles are charged using electricity, which is again from the grid, but it creates a GHG of a diesel car or a petrol car. So this is one way to look at reduction. And then the supply chain in terms of scope 3, how do you work with your suppliers to reduce and work with them and encourage them also to do what you are doing is the scope 3. And also looking at my logistics to see that my carbon emissions come down. So these are broadly the various mitigation measures. To understand in terms of the projects that we have undertaken and just a glimpse of the various projects that we have completed or in the various phases. We have set up a 1.8 megawatt or 1,800 kW of solar project inside our own campus. We put up solar water heaters for substitution boilers which we are using the LDO. Clean fuel substitution, wherever we are using kilns which were fired with LDO, we are substituted with liquefied natural gases. Wherever we were using water and pumps to a great extent, not to everywhere, wherever we substitutable projects we identified and substituted with rainwater. So that calls for setting up a rainwater harvesting, collect the rainwater and start using it inside the process itself, thereby reducing the need to use fresh water from the suppliers. Rainwater recycling, then replacing pumps, energy efficiencies. How do you improve energy efficiencies? Using energy efficient pumps, energy efficient motors, replacements, process changes. Inside your process, we have a silicon carbide plant where we have brought about a significant design change in-house, which has helped us to reduce our carbon emissions significantly, also the energy reduction. And similarly, inside the process also, many projects I would touch upon. And on the plan is to have a solar water heater for canteen, also rooftop solar for our special economic zone plant. This is one one sample project I wanted to share in terms of scope 1. As I said, in scope 1, our significant emission is carbon. Create a change in our reduction of scope 1 emission. Tons per fusion was the release, and we were emitting close to 88 tons in a month. So if you look at this particular process, we modified it during the beginning of 2018-19, and we started a circular economy project wherein The recycling of the materials helped us to bring down the carbon emissions from 88 to 68 tons per month. And from there, our R&D developed a product which is a synthetic version. So I don't need a bauxite to be mined and taken as a raw material. I use a synthetic process of manufacturing. So from a chemical reaction we produce in terms of the production in this plant, and that has brought about a phenomenal reduction of 3.5 tons per month. So you can see that how your actions inside the factory through improvements in terms of your own actions in terms of first reduction and then followed by a quantum jump in terms of a development of a new alternative process of production helps you to significantly reduce your carbon emission. The process has been developed in-house and patent has been applied. The patent is pending. We have very similar processes done in many of the raw material substitutions and projects, which has been patented already. And this one, in this particular project, the patent is pending, but the product has been well established as a substitute for the regular brown fused alumina that is produced conventionally. Again, in terms of renewable energy substitution, we have a 12 megawatt hydroelectric power project, which helps us to substitute 30% of our energy consumption in a year. So 30% of our consumption gets substituted using renewable energy, which is hydropower. And further 20%, we still looking at a substitution with solar and which is what I said, talked about 1800 kW solar project, and also through the green energy procurement from the open access. Today, you can buy power from outside the grid. You need not buy power from the supplier of electricity, which is in Kerala. It is Kerala State Electricity Board. You can buy green energy or substituting with green energy purchase, which also significantly helps us to bring down our scope 2 emission. So tree plantation, again, looking at looking at all aspects of reduction. So one area that has been looked at that has been done over many years now. And if you come to the factory, I would say those who have come to the factory would like to understand that it's a factory inside the forest or a forest inside the factory, whichever way you want to say it. And the rainwater harvesting pond into the ground, which helps these trees to also survive without, once it has a tree, you don't have to water it. It needs water from the underground. So the water table has to be enriched. So we do not let out any rainwater to flow out of our campus. We are allowing it to be collected in the percolating pits and allowing it to go into the Mother Earth by enriching the water table and thereby providing the rich resource requirement of water for the plants during the summer. These are the project that I've talked about. The 1800 kVA solar project in itself creates 18,17,000 kgs of carbon dioxide reduction per annum in terms of substituting the power. So these are the various sample projects that I would share with you in terms of it's very difficult for the times allotted to go through each and every individual projects and how it has impacted the reduction. But to get a flavor of 21 onwards, we have been significantly investing and looking at various action plans to reduce our GHG emissions. And the company is looking at carbon neutrality by 24-25, which is a very ambitious goal. But even otherwise, in terms of at least scope 2, we are looking at substituting 100% reduction and achieving carbon neutrality in terms of energy requirement for scope 2 at least. And going forward, before closing, I think we didn't talk about the scope 3 emissions, but the job is never complete. While we continuously look at reduction of scope 1 and scope 2, which is in our control, we need also look at scope 3 to get started on it. So we have started the work on scope 3. We have engaged the same agency, CII, Green Business House, Hyderabad, and they have come and conducted the training program last month. And the data collection process has been kickstarted based on the guidance. And once the data collection is completed and validated by them, the inventorization process, similar to what I have shared for scope 1, scope 2, would be completed by October, November. And once that is completed, we would be working out the mitigation project in discussion with and support with the CII Green Business House. So we have set a very modest target of 5% reduction because scope 3 emission is not exactly in our control. We would also have to work synergistically with our suppliers and vendors. So we are looking at a and also our customers. So we are looking at a 5% evolved actions would continue to be there to reach the goal that has been set for us. So overall, the satisfaction is recognition in terms of what we have done. So over the last many years, we have been consistently getting the Energy Management Award of SEAM from silver to gold to this year. I'm very happy to share that we have been selected for the Platinum Award, and the award function is on 21st of this month at New Delhi. Last year we were also happy to receive the first prize in terms of the energy conservation from the Energy Management Center to receive the award from the Chief Minister of Kerala and City Minister of Kerala. Our improvements and innovations that have been done have been recognized by Kerala Management Association with the Innovation Award, Manufacturing Innovation Award last year, 2023, this year. And the Institution of Engineers have been consistently rewarding us with the Industry Excellence Award, which is basically on this sustainability parameters along with the business results. So business is stakeholders' aspirations and goals, but at the same time, looking at sustainability is also equally important. And we have gone to EcoVadis. Now, so those who are uninitiated about EcoVadis is a globally recognized assessment platform where you need to pay a good amount of fees for them to look at your processes on 4 key parameters, which is basically environmental impact, human rights, and procurement practices and ethics. And they give you an award rating. So we have been consistently getting twice the bronze award. So again, it means that once we kickstart we look at targeting a silver in the coming year. So thank you very much. With this, as promised, I have closed my presentation 6 minutes ahead of schedule. So any questions that participants may have, the floor is open.
സംശയമുള്ളവര് ഹാൻഡ് റൈസ് ചെയ്യേണ്ടതാണ്. It was a nice presentation, sir. Very clear also.
Thank you.
Hello, sir. Am I audible?
Yeah, very much.
I'm Sri Lakshmi, environment engineer, Ernakulam District Office, Pollution Control Board. So I'm very happy to see that industry under my jurisdiction has taken a lot of initiatives to reduce the greenhouse gases. So very happy to see, and I take this opportunity to appreciate you, sir. Presentation also was very good and it's really informative. Sir, I have one doubt. So I have seen that many initiatives are taken by the company. Now, are you uploading these details in any of the platform of ministry? The achievements that are made by the company to reduce the carbon footprint, whether you're uploading that in any of the website?
Madam, I shared my presentation. If you look at previous one, I talked about this EcoVadis. EcoVadis is a platform where we upload the entire, not only our practices in terms of the GHG emissions, what have been presented, but it asks for much more detail. It is a very globally recognized assessment platform where our suppliers and our customers get to see what we have done, but they would validate it before they actually accept it. In terms of environmental impact, in terms of labor impact, in terms of the national level, I don't think we have actually employed a third-party agency, CII, Godrej Green Business House, to quantify and calculate and arrive at the mitigation project, support us in the whole process. But other than that, I think like EcoVadis, I don't know whether there is any platform available in India where you can upload this greenhouse gas emission data to be uploaded. But in international thing, there is SBTI, Science-Based Target Initiative, which we are now looking at also registering and uploading our data there.
Yes. So these data is available in the public platform.
Yes.
Public domain is available. That is EcoVadis.
EcoVadis, yeah.
Okay. So thank you so much.
Thank you very much for giving me this opportunity, madam. I don't know whether you were there. I thank you very much. There are two hands raised. I'm not sure who are the people.
Sir, I think one is yours.
I have actually not raised it, but in the morning also somebody called out. Let me check. Is it now?
No, it's not. Now also it's showing.
No idea. It doesn't get reset, I believe. Morning I had spoken for the first presentation. So maybe when I raised it, it is not getting reset after that.
Can you press the button again? I think now also
Yeah,
it's showing.
I tried it.
Now it's gone, sir.
Okay, thank you.
സംശയമുള്ളവർക്ക് ഹാൻഡ് റൈസ് ചെയ്യാം.
I take heavy topic post lunch. So
സാർ അവിടെ സാറിന്റെ കമ്പനി പ്രമിസസിലെ പ്ലാന്റേഷൻസ് ഉണ്ടെന്ന് പറഞ്ഞു. അത് ഏതെങ്കിലും സ്പെസിഫിക് സ്പീഷീസ് ആണോ സാർ?
We have actually worked with the Forest Control Research Institute, Pichi, to plant the saplings, and they have been guiding us. So if you come to Korati plant, where the carbon dioxide emissions is there, they suggested to go for bamboo plantation. They said that bamboo are biggest carbon sinks, act as a carbon sink. So we have, if you come there, you will see a lot of bamboo. But apart from that, other trees, fruit growing trees, many growing trees are planted. In if you come to Kalamasheri at the 2018-19 or beyond that, they helped us with this teak put plants, the saplings which have been sapling. But they have we have now made it very widespread. So species, based on what they suggest, we have gone about it, and now they are supporting us in developing a butterfly garden inside our campus at 2 places.
Okay, sir.
So butterfly requires a specific conducive atmosphere and conducive plants. So they would first assess the site and then identify the spot which is ideal for it. And then they would, once then they give us a pilot plans for us to put it. And then they come and evaluate it whether butterflies are attracted or leaving. Full-fledged butterfly garden.
You have diesel generator in the company? Have you installed
We
that?
don't have a big diesel generator. We have pumps can be run with diesel generator. Otherwise, we don't have a generator to run our production.
Its capacity?
Must be less around 100 kV or 50 kV.
Okay. Suppose this is 125 kVA, then you can go for retrofitting. So that means you can achieve more carbon reduction if you install that also. It's an additional fitting to reduce the carbon emission. So that also is achievement.
Sure.
For 100 kVA, it's not nothing. Now from 125 kVA, it is mandatory.
Okay. We don't have that capacity.
Okay.
Any more questions?
I don't think so.
Sir, അപ്പം മൈൻഡ് അപ്പ് ചെയ്തോട്ടെ സാർ?
ആയിക്കോട്ടെ.
ഓക്കെ, ഫസ്റ്റ് ഓഫ് ഓൾ കൺഗ്രാറ്റ്സ് സർ. സോ ജനുവരി അടുത്ത വർഷമാണെന്ന് തോന്നുന്നു ഗ്രീൻ ഹൗസ് ഗ്യാസ് ഇൻവെന്ററൈസേഷനെ കുറിച്ചും എമിഷൻ കാൽക്കുലേഷൻസിനെ കുറിച്ചും ഗ്രീൻ ഹൗസ് ഗ്യാസ് മിറ്റിഗേഷൻസിലെ വിവിധ അപ്രോച്ചുകളെ കുറിച്ചും ഒക്കെ നമുക്ക് ഒരുപാട് വിശദമായ ക്ലാസ്സുകൾ നടത്തുകയും കാർബോറണ്ടത്തിൽ നടത്തുന്ന ഇനിഷ്യേറ്റീവ്സിനെ പറ്റി സംസാരിച്ച് വളരെയധികം വാല്യുബിൾ ആയിട്ടുള്ള ഇൻഫർമേഷൻ നൽകിയ ശ്രീ നായർ നന്ദകുമാർ സാറിനെ ബോർഡിന്റെ പേരിലും ഈ വെബിനാറിൽ പങ്കെടുത്ത ഓരോരുത്തരുടെ പേരിലും എന്റെ വ്യക്തിപരമായ പേരിലും നന്ദി അറിയിക്കുന്നു. ഇന്നത്തെ വെബിനാറിൽ നടത്തുന്നതിന് വേണ്ട മാർഗനിർദ്ദേശങ്ങളും പിന്തുണയും നൽകിയ ബോർഡിന്റെ ചെയർമാൻ ശ്രീ സുധീർ സാറിനും മെമ്പർ സെക്രട്ടറി ഡോക്ടർ ഷീല എം മാഡത്തിനും പിന്നെ ഈ വിഷയത്തിൽ കൈകാര്യം ചെയ്ത സുമി മാഡം, പ്രേംലത മാഡം, ശ്രീ നായർ നന്ദകുമാർ സാർ, എല്ലാവർക്കും കൂടാതെ ഇതിൽ പങ്കെടുത്ത് ഇതൊരു വിജയമാക്കിയ ഓരോ വ്യക്തികൾക്കും ബോർഡിന്റെ പേരിലും എന്റെ വ്യക്തിപരമായ പേരിലും ഞാൻ നന്ദി അറിയിക്കുന്നു. താങ്ക് യു സർ.
Thank you all. Thank you.